Okay, so the last section in chapter 5 deals with simplifying and using square roots, okay? So before we can actually go into the square root, I want to go ahead and kind of give you some numbers and their perfect squares, okay? So let's define a perfect square first. So a perfect square is the square of a whole number, okay? Now, I know it's kind of redundant, but I need us to examine this. So, for example, 3 squared equals 9 is considered to be a perfect square. Now, here's why. A long time ago, we learned that a square is a shape where all 4 sides are the same length. So, if this is length 3 and this is length 3, and you were to count all the blocks on the inside, you would get 9, which is a perfect square. So now that we kind of know what a perfect square is, you know a bunch of them. And what I mean by that is this. So here's the number. And here are the perfect squares. All right. So if the number is 1, the perfect square is 1. 2, perfect square is 4. 3, perfect square is 9. We just went over that. And now I'm just going to go ahead and start labeling them. So we got 4 and 16, 5 and 25, 6 and 36, 7 and 49, 8 and 64, 9 and 81, 10 and 100, 11 and 121, 12 and 144, 13 and 169, and there's even more, all right? And you can go ahead and you can find the other ones. I mean, there's an infinite amount, okay? But to understand square roots, we need to know perfect squares, okay? So now the next thing I'm going to do is I'm going to introduce us into the square root of a number. All right. So the square root of a number, first thing I'm going to do is just go ahead and define something real simple. A number whose square is m is called a square root of m. Sorry, wrong letter. Now, I think this sentence right here is a little confusing for us that are learning this. So I'm going to clarify it by writing this, okay? If m to the second, let me change these letters because your book uses them backwards. That's fine. If n to the second equals m, then n is a square root of m. So directly underneath in red, I'm going to give you numbers, and it should make sense. So if 5 to the second equals 25, then 5 is a square root of 25. Okay? Another one to look at would be something like this. If 9 squared equals 81, then 9 is a square root of 81. Okay? Now, we do use notation for this. Okay, we do use notation. And the notation is right here. So, the square root of 81, let me write that cleaner. The square root of 81 equals 9. Now, before we go any further, I want to label stuff. First, The number 81 has a special name. It's called the radicand. Okay? This symbol that I drew is called a radical sign. Okay? And technically, although we don't write it, there is a 2 right there where I just wrote that little 2 in red, and that has a very special name. It's called the index. Okay, so there's a lot of things going on here. Now, if there is no number written, so I'm going to rewrite the problem off to the right-hand side in red. So if we don't write a number here for this index, we assume it to be a 2. Okay? You just assume it to be a 2. If it's something else, we will write it. You can have a 3rd root. You can have a 4th root. You can have a 5th root. You can have a 6th root. It doesn't matter. If nothing is written, though, then we call it a 2. Okay? So if you think about this, and I'm going to scroll up here a little bit. If you think about this table that I have written here, if I want to start with the number and go down to the perfect square, then I have to square it. Okay? Now, in blue on the far right-hand side, if I give you the perfect square and I want the original number, that is when we use the square root. So, the square root of 100 equals 10 because 10 to the second equals 100. Another example. The square root of 49 equals 7 because 7 to the second equals 49 and so forth, okay? Let me get rid of this stuff. There we go. All right, I'll do one more. The square root of 1 equals 1 because 1 squared equals 1. So there's a relationship in between these two rows. So I'll zoom out just a little bit. And I'll scroll over if it'll let me. So remember, if we go from the number to the perfect square, we square the number. If we go from the perfect square back to the number, then you take the square root. Okay? Now, there is something that we need to be very careful about. Okay? When you have a square root sign, okay, when you have a radical, you are not allowed to have negative numbers underneath the radical. No negative numbers. So, the square root of 4 equals 2. That makes us very happy. However, the square root of negative 4 is what we call a non-real answer. Okay? Now, to demonstrate that, I can go ahead and get a calculator out and show you. So let me find my calculator. Here it is. I'm going to try to maximize this as much as I can. So if you look at the calculator, I can do the square root of 4. And like I said, on the calculator it says number 2. And that's fantastic. However, if I do the square root of negative 4, watch what the calculator says. Watch what it says. Error, non-real answer. Okay? So if you're asking yourself, what does that mean? Well, here's what it means. We've been learning all about these numbers. All right? We learned about whole numbers. We learned about integers. We learned about fractions. We also learned about decimals. A non-real answer is an imaginary number, okay? Another way to say that is a complex number. All right, now, you may think, this is going to be the pun right here. You may think I'm making this up, like I'm being imaginary, all right? But I am not, okay? Because there are things called imaginary numbers. So, without going too far into it, All right. Without going too far into it, I'm just going to go ahead and just go over to here and just show you that the letter I is equal to the square root of -1. And that is what we call an imaginary number. So these imaginary numbers do exist. All right, you can go to the Google machine and just type in imaginary numbers, maybe hit integers, and there's all this stuff about imaginary numbers. Now, you will not see imaginary numbers in your math course until maybe, and I'm really stretching this out here, maybe MAT080, but definitely in MAT108. So if you have me for MAT080 or if you have me for MAT108, definitely MAT108, you will see complex numbers, MAT108. Okay, but other than that, just know for now, if you got a negative underneath the square root, you get a non-real answer. Okay, now you can have this problem right here. You can do negative square root of 4. Okay, notice the negative symbol is outside of the radical, and that's okay. So this is really -1 times the square root of 4. Now, according to the order of operations, all right, you do radicals first. So whenever you see that radical symbol, you go ahead and simplify that first. So this is going to be -1 times the square root of 4 is 2. So the end result is going to be -2. Okay? Same thing as this example. Negative square root of 64, think of it as -1 times the square root of 64. Now, we're going to simplify the radical first. So we get -1 times 8, which is -8. Okay? The problem becomes, what is the square root of 20? Okay? Now, if I scroll all the way back up, you know what I'm going to do? I'm going to pause the video. I'm going to copy and paste what I want. All right, I'm back. So if you need to, pause the video and write down this table, okay? So here's the issue. This number 20 is not one of my perfect squares in the bottom of this table. It's not one of those perfect squares. So what we're going to have to do here, okay, is we're going to have to estimate this. All right, now, to estimate it, you need to think about, okay, well, since I'm dealing with the square root of 20, we know 20 is not a perfect square. What we're going to do is let's find what two perfect squares that we know of will 20 be in between. Okay, so if you think about this, 20 just happens to be in between 16 and 25. So the square root of 20 must be in between 4 and 5 when simplified. Okay? So that is how we estimate what a radical is. Okay? Now, let's try another one here. Let's try another one. So what I'm going to do is I'm just going to erase what we don't need because I'm going to leave this table. I want this table up here again. Okay, so here's our next problem, the square root of 60. So we know 60 is not a perfect square, so we're going to find two perfect squares that 60 will be in between. So there's 64, and here's 49. So I know 60 is going to be in between 49 and 60. And since 60 is closer to 64, Okay? If I were to take a guess, I would say this is going to be like 7.8 or 7.9 as a radical. All right? Which leads us into our next topic. Well, hold on. I'm moving too fast. Let me write the answer here. So the square root of 60 is going to be somewhere in between 7 and 8. Okay? Now, if you were to ask me, well, Mr. Float, do you think it's closer to 7 or do you think it's closer to 8? I would say that it's closer to 8. Why? Because 60 is closer to 64. And like I said, this leads us into our next topic, which deals with, well, how do you calculate this using a calculator? All right? Because you're going to have some questions that it says, use a calculator to find the approximation of the square root of 60 or any other radical. So to show you, I'm going to show you two ways because I don't know what calculator you have. All right. So the first way, we're going to use my big fancy one. Okay. So let's turn it on. So my square root button is going to be right above the x squared. So you can see where the cursor is. It's in the first column. It's like the fourth or fifth button down. So since it's in blue, that means I got to hit the shift key first, or the second key. So second, x squared. Now you can see the radical symbol. I type in 60. And remember, my guess was somewhere like 7.8 or 7.9. So when I go ahead and write this, or calculate it, the square root of 60 is 7.75. We'll round it to two decimal places. So square root of 60 equals 7.75, which is really, really close to 7.8 if you think about it. So if you have one of these like fancy calculators, you can just type it in. Now, if you don't have a fancy calculator, your computer has a calculator. Now, here's how you find it. Lower left-hand corner, where it says type here or search. If you're using a Windows, you can just click there and just type the word calculator. It'd be nice if I can hit C first. So right here's our calculator app. You would just click on it. All right. And here it's just a standard calculator. Now the hamburger menu, that's what these three bars mean. All right. You can click on that and you can change your calculator to whatever you want, but we're going to leave it standard. Now to use this, I think what you have to do is hit 60 first, and then you hit the square root button. And it gives you the same exact thing, 7.74, but we rounded it to 7.75. If you have a Mac computer, you got to go to the YouTube and just type in Mac, Mac calculator. Probably the most universal would just be go to the Google machine. Literally just go to Google. All right, so let me go to the Google machine. And in the search bar, I'm just going to type in square root of 60. And just hit enter. And they have their own calculator on their webpage, and you can just use that. Okay? So I hope this helped, all right? Because we're only estimating things here. All right, we're only estimating square roots because sometimes it's just not there for us. Now, the last thing that I want to go over, I guess I got to get rid of this. There we go. Would be square roots and exponents. Okay? So this is going to be our last thing. So square roots with variables and exponents. All right. So recall that the square root of, and I'm going to use a different number here. Which one haven't I used yet? We'll do 9 again. Recall that the square root of 9 equals 3 because 3 to the second equals 9. Okay? Well, you can apply the same idea here. All right, you can apply the same idea with variables. So the square root of x to the second equals x because x squared is going to equal x squared again. So what I'm really saying here is this. Do you see this 9 directly above? Well, we could have rewrote 9 as 3 to the second power. Okay? Now the square root of 3 to the second power equals 3 because we know 3 squared equals 9. So this right here kind of follows the same exact trend. Okay? So square root of y squared is going to equal y. Square root of z squared equals z. Square root of m to the second power is going to equal m. Anytime the index and the exponent match, you're just going to write the variable raised to the first power outside. Okay? So now we can kind of do more complicated simplifications here. And if you're asking yourself, well, what do you mean by that? Here's what I mean. We can actually simplify the square root of 81 times x squared. Okay? Now, all you got to do is break it down. First, you got a number. It's a perfect square. So the square root of 81, we know is 9. And then the square root of x squared is x. So this is 9x. Okay? I could do another example here. I'll do one that we haven't seen yet. 225. So this is the square root of 225 times y squared. Now, the square root of 225 is 15. And the square root of y squared is going to be y. So this is just going to be 15y. Okay? I could try to trick you a little bit. No, I don't want to say trick, but I can make you think about this. How about negative square root of 121z to the second? Well, remember, the negative is on the outside, so that's okay. We can have that. That's fine. So, negative on the outside. Square root of 121 is 11. Square root of z to the second is z. So this is going to be negative 11z. Okay? I can even throw this in there if I wanted to. I could throw multiple variables. All you're going to do is just do one step at a time. That's it. So the square root of 16 is 4. The square root of x to the second is x. And the square root of y to the second is y. Okay, I'll do one more like this here. Okay, I'll do one more like this. So the square root of 196, x to the second, y to the second, z to the second. Okay? Once again, this looks really complex. However, you're going to do just one step at a time. So the square root of 196, I'll help you with that. It's 14. The square root of x squared is x. Square root of y squared is y. Square root of z squared is z. So notice it's just 14 times x times y times z. All right? And that's going to be it for this video. So I hope this was informative. They do get more complicated, but you won't see that until MAT080. For now, just know the square root of a number is a perfect square. And then if you have variables, just look at the exponent. If it's a 2, just rewrite it as a variable with just one exponent. And that'll be it. See you in the next chapter. Later.